Hi there everyone, this is Teacher Epoy and welcome to my YouTube channel. For this session, we will be talking about the remainder and the factor theorem. Now let's begin with the remainder theorem. So the remainder theorem states, if a polynomial f of x is divided by x minus a, the remainder is the constant f of a, and f of x is simply equal to the q of x, that's the quotient, times the divisor x minus a plus f of a, which is our remainder, where q of x is a polynomial with degree 1 less than the degree of the f of x. Now, let's have this example. So we are going to be finding f of 3 for the following polynomial function. So when I say f of 3, we are going to be substituting three over x here. So this now becomes 5 times 3 squared minus 4 times 3 plus 3. Okay? Whatever is the value here of your f of x, meaning the value of your x there, you will substitute that over the variable. So let's do the exponent first, and let's multiply this. You will be getting 5 times 9 minus 12 plus 3. And then you multiply 5 and 9, you'll get 45, bring down 12 and 3. And then you do the operation, 45 minus 12 plus 3, you will get 36. So we are simply doing the substitution process here. Now what if I'm going to be using the synthetic division here? I will be dividing. We have the same given ganiya. We have 5x squared minus 4x plus 3. But this time, I will divide the polynomial by x minus 3. So I'll be writing 3 there. The opposite of negative 3 is positive 3. The coefficient of x squared is 5. Negative 4 for x. And positive 3 for the constant term. So the first step, bring down 5. Then you multiply 3 and 5. You write 15 there. Then you combine negative 4 and 15. You're going to get 11. Then multiply 3 and 11. You're going to get 33. And you have 36 there. Now, you have noticed now that the result, when you substitute 3 over the expression, and when you do synthetic division, they have the same result. So meaning, if I'm going to substitute 3 over the expression, and whatever the result is, that is simply the remainder, because that is the remainder when we did the synthetic division. So you can do this method here by substituting, or you can do synthetic division in finding the remainder. Now, let's have other examples. Now, you have noticed now that f of 3 is the same as x minus 3. Take note of that. The same answer sa f of 3 and also dividing the polynomial by x minus 3 using the synthetic division. Now, let's have more on synthetic division. Let's have this one. Let's use the synthetic division to find g of 4. When I say g of 4, the divisor is x minus 4. So just take note of that. G of 4, you can write that in as a divisor, x minus 4. So the process is simply bring down 5, multiply 4 and 5 to get 20 here, and then you have 13, negative 13 plus 20, you'll have 7 there. Multiply 4 and 7 to get 28. Combine, you'll get 14. Sorry. And then 4 times 14, you'll have 56 there. You combine them again, you'll have 9. And then 9 times 4, you'll have 36. Combine, the remainder is 37. So when you divide this expression by x minus 4, the remainder is 37. What if I'm gonna divide the same expression by negative 2? So you have noticed now that our divisor is x plus 2. I will divide this by x plus 2 now. So I will be using synthetic division. So there you have it. So the process here, you already know that. Bring down 5, then multiply, then combine, then multiply, combine, then multiply, combine, then multiply, and the remainder is 223. Okay? So let's go to the binomial or the factor theorem. The binomial x minus 3, or x minus a rather, is a factor of the polynomial f of x if and only if f of a is 0. So when doing the synthetic division, if you'll be having a binomial x minus a, and doing subsynthetic, you will have a 0 denominator, meaning 0 remainder there. Meaning, if the remainder is 0, meaning the binomial is a factor. Okay? Now, let's have examples. What if I'm going to be having this? What if I'm going to divide this expression by x minus 3? Now, my question is this. Is x minus 3 a factor of that polynomial? So, by doing synthetic, we will now determine whether the given binomial, the divisor, is a factor. Now, let's do synthetic now. Now, you have noticed now that the remainder is 0. So, check na to. Bring down 1, multiply, you'll have 3 there, and you have combine 7, multiply, that's 21, combine, that's 6, you'll have 18 there. The remainder is really 0. So meaning, since the remainder is 0, x minus 3 is a factor of x cubed plus 4x squared minus 15x minus 18. And take note, we can also write this down as an expression. So writing that down as an expression, you will be having x squared plus 7x plus 6. And by doing factoring, you will have factors x plus 6 and x plus 1. So we now have the factors of this polynomial are x minus 3, this one, x plus 6, this one, and x plus 6. And I will introduce the word root or zeros. So the number we are using here is already a root. And take note, if you will go to the factors, what is the opposite of negative 3? It's positive 3. What is the opposite of positive 6? It's negative 6. What's the opposite of positive 1? It's negative 1. So therefore, the roots are 3, negative 6, and negative 1. Now let's have more examples. This one. What if I'm going to divide the polynomial by x minus 8? So doing synthetic division, so we will have, I'm going to be having positive 8 here. I'm going to have 1, negative 11, positive 14, and you have 80 there. So let's have bring down 1. And then 1 times 8, that's 8. Negative 11 times 3, that's combining them, that's negative 3. And then you're going to have negative 24 there. Combining the 2, you're going to have negative 10. Multiply that, that's negative 80. It's 0. So we now have one factor. The one factor that we have is x minus 8. Now let's write this down as an expression. X squared minus 3x minus 10. And let's do factoring now. So we have plus and minus, x and x. Factors of 10, when subtracted, it's 3. 5 and 2. 5 is negative. 2 is positive. So we have there x minus 8, x minus 5, and x plus 2. And the roots are, we have opposite of negative 8, positive 8. The opposite of negative 5, that's positive 5. And the opposite of positive 2, that's negative 2. And there you have it. Those are your roots, and those are your factors as well. Okay? Now, so let's have another example. Okay, what if you're having this one? Let's do synthetic again. So we have negative 6 there, and we have 2, 7, negative 33, negative 18. So doing synthetic, bring down, multiply 6 and 2, that's negative 12. Combining them, you'll have negative 5. You'll have positive 30, negative 3 there, and you have positive 18 at 0. Right? So we already have one factor here, that's x plus 6. Now let's have the other factors. I will be writing this as 2x minus 2x squared minus 5x minus 3. So how do I do factoring here? You still remember the method I taught you about how to do factoring when if ever x squared has a coefficient greater than 1. So you'll be having 2x all over 2 there. So I can now have plus and minus for this, right? And multiply 3 and 2. The product is 6. What are factors of 6? When it's subtracted, it's 5. So I'm going to have 6 and 1. 6 is negative, and 1 is positive. Let's do further factoring. So you have 2x plus 1. And common here is simply 2. You have x minus 3 there. All over 2. And I'm going to cancel 2. So the factors are, you have x plus 6. You have 2x plus 1. And you have x minus 3. And I can write down the roots as, you have 6. How do you write 2x plus 1 as a root? So if I'm going to have the solution there, you have 2x plus 1 is equal to 0. So 2x equals negative 1, dividing both sides by 2. So you have negative 1/2 there. And then the opposite of negative 3, that's positive 3. So those are your roots. Now let's have more examples. What if you are given this one? What if you're given this one? You have, let's have first this one. What if you're having x squared minus, not x squared, but x cubed, not x squared. X cubed minus 7x plus 6. And you are not given a divisor. So, the one thing that you will consider is simply look at the last term. The last term is positive 6. So, the factors of positive 6 are simply, we can use positive negative 1, positive negative 2, positive negative 3. I can even use positive negative 6. Now, my technique here is simply to use the smallest possible factor first. So, I'm going to be using x, that's positive 1 and negative 1. Now, let's begin with negative 1 first. So, let's do synthetic now. So, I'm going to have negative 1 over here. Okay? Now, the coefficients are 1, 0 for x squared. Since x squared is missing, you need to write 0 there. Negative 7 and 6. Now, let's do synthetic here. So, this is now 1, bring down 1. So, you have 1 there. Negative 1. And then you have negative 1. Positive 1. That's negative 6. That's positive 6. And the remainder is 12. So, this one, I cannot use that. Why? Because the remainder is not 0. So, I will be using positive 1 now. Let's try positive 1. So, this time, it's positive 1. So, 1, 0, negative 7, and 6. So, we now have bring down 1. And you have 1 there. 1. That's 1. That's negative 6. Negative 6. That is 0. So, therefore, how do you write this as a divisor? Diba, you can write that as x minus 1. So, you already have one factor. X minus 1 is a factor. So, what about the other factors? So, I'm going to be using the result here. X squared plus x minus 6. I will be doing factoring now. So, I will have x plus 3 and x minus 2. So, the other factors are x plus 3 and x minus 2. So, these are my factors. And what are my roots? The roots are positive 1 for x minus 1, negative 3 for x plus 3, and positive 2 for x minus 2. And there you have it. Those are your factors, and those are your roots. So, thank you everyone for viewing my tutorial video about factor and remainder theorem. Till next time.